right, so it's 5 p.m. at least here in Germany. So yeah, hello and welcome. I'm Steven Schwenke. I am the host of the event series of Hack Talk, which you can see in the back. This was the name of this series of events up until end of last year. And then I renamed it and I kind of refactored it and added a new feature. So it's basically not a real refactoring, but it changed, and you see the new version here. So just a couple of information about this one. This meeting is being recorded, but it is only for presentation on YouTube. I hope everything is going well with the recording, and this is showing up on YouTube later on, but without your name. So if you unmute yourself, or if I call your name that you showed here in the participants list, then this is the only thing about you that is that is being recorded. If you have some thing against that, please write me an email afterwards as quickly as possible. Then I'm going to cut that out. So much about the recording. Then to the series of events here, and I'm going to start the poll so that you can just give me some feedback. Thanks for this. Only 2 questions, and I'm very curious about the answers. So I renamed this series of events to Tech Dev Circle, and the basic idea is to have regular tech talks about topics that are interesting for tech enthusiasts, for developers, for architects, and everyone interested in software development. And the basic common topic is everything that can help us in doing our work. These topics are, and of course I noticed that this page is in German because this event is originated in Germany, and maybe depending on your answers in the poll, I'm going to have more English talks. We will see that, but every talk is introduced with where it is on the Gartner hype cycle. And as you can see here on the home screen, on the trailer, Harry already introduced his topic that he's going to talk about today: monitoring Kafka-based applications with distributed tracing and with OpenTelemetry. We already talked about this, and we said that it is basically ready to use for all of us. And down here, this is the second kind of dimension where I'm going to have my topics located in. And this is a topic that is interesting for experienced developers as well as for beginners, because it is a recent topic, and you can use it despite the fact if you are at the beginning of your career or if you are more advanced. As you can see here, the skills or the set of skills is listed here together with all of the talks that have been here in the past. It's actually not all of them, but the most. And you can have a look at the protocols here. And here you can find a list of the past talks with together with the trailers or with a full recording. And this is also new, hoping that I have recordings for each and every talk here. And of course, you can download the slides when they are here, for example, like this one. So that this series of events is a comfort zone for software developers, presenting important and relevant topics. And if you are thinking about, hey, yes, I have a topic, or I may have a topic that I could present to other interested parties, then please contact me, because I am a huge fan of the IT community, because sharing our knowledge is something that makes our branch special. And this is why I wrote a book on the not the art, but on the act of giving a talk, a technical talk or a non-technical talk for developers. And I'm giving away free coachings. So if you are thinking about being a presenter, being a speaker, despite on for conferences or here in this series of tech talks, then please contact me, and we can see if your topic is interesting and how we can introduce it here in this event series. All right, so back to the home screen. Last thing I want to say is that you can subscribe in multiple ways. So there is a Mastodon feed, there is an Atom feed here. You can have you can subscribe to a newsletter here, and of course every event has an iCall file and so on. And this is also presented here in Meetup, and there's a group for that. I saw that in the last days a couple of you, a lot of new participants showed up here, which is great. So subscribe to that as well. And also we are presented on LinkedIn. So if you are interested, there is no way um, to not see new events. And this is really the last thing, new events. This is kind of a talk out of the turnus of the usual turnus, because there's supposed to be one talk each month, the first Tuesday of each month. And this is why again, already next week I'm going to present, but in German. Maybe we can also have this in English later. A talk about mastering developer certification. So why are certifications for developers interesting? And I'm going to present how to study on the AWS related certifications. And later on, we will also have a topic for GitOps and for um, authorization with open source software. So this is just a teaser for all of the topics that are coming up. And if you are really interested, this is why I had the poll, then I could make sure that we have those topics in English as well. So regarding the poll, most of you are the first time for the first time here. So welcome. It's nice to see you all here. And yeah, roughly one third is English speaking only. So, okay, I will have a look at that later and decide if we will have more English topics here. But so much for the yeah, for the introduction part. Now, Harry, so I'm so glad that you are here, and we have been introduced by a yeah, by a person that is also very interested in the IT community and very, very active. So thanks again, Olivia, for that one. And I also talked with you when we filmed the trailer, and I have the feeling that you have a lot to say. You already said that there will be a live part at the later part of your presentation. So this is why I'm handing to you Harry Kimpel with the monitoring Kafka-based applications. I'm going to stop my screen share so that you can share for on your side.
Yes. Can you see my screen okay?
Not yet, but it is coming up. Yes, now we can see it. Okay. So Harry, the stage is yours. Have fun.
Perfect. Thank you so much, Stephen, for the introduction and all the nice words. I also work very closely with Olivia on community, which is very close to my heart. I like sharing knowledge. I like mentoring younger or early in career people. So that is definitely an area that I'm really interested in. I'm happy to share this talk today on monitoring Kafka-based applications using distributed tracing with OpenTelemetry. That is a lot of words. I actually also have, built another talk where I'm not necessarily only focusing on Kafka, basically on event-based systems, but in the sample, in the demo that I'm sharing later throughout this presentation, I'm using Kafka, but basically you could apply this to any other event-based systems. But of course, Kafka is very popular. I'll go into details on what distributed tracing is quite briefly at the beginning, and also like a short introduction into OpenTelemetry for those who haven't heard about this before. But without further ado, let's get started. So my name is Harry Kimpel. I'm a principal developer relations engineer at New Relic. I work for New Relic, of course, but everything, and this is also important for me to share, everything I'm sharing today is applicable to any other observability vendor, any open source tooling that you may be using. So I'll be using New Relic in the demo later as my sink for all the telemetry that we're capturing. But basically, you can target any other backend that of your choice. I've been a passionate software craftsman for many, many years. I started my career, many, many moons ago. I started basically in the more Microsoft developer ecosystem. I began, long time ago in Visual Basic 3 and Visual Basic 4. Um, Good that these days are over. But once you are in a certain ecosystem, you tend to stick. But of course, throughout the course of the years, I have seen many technologies, many programming languages, and so on. I'm with New Relic since 2017. And if I'm not in front of a computer, which happens also quite a bit, I'm outside. This is actually a picture of my area that I'm living in. I'm based south of Munich, Germany, more or less at the border of Austria in a county called Garmisch-Partenkirchen. I like all the things outdoor, hiking, climbing, biking. This time of the year, still skiing, and the next weekend is basically the last weekend for the local skiing area where I'm typically go on a weekly basis. I guess no talk without any form of AI. I recently asked ChatGPT, and you may know that this has some kind of memory function, so it remembers your questions and your prompts and so on. And I recently asked, based on what you know about me, draw a picture of what you think my current life looks like. And interestingly, it came back with this response. Here's an illustration capturing your developer life surrounded by the inspiring Bavarian Alps. And I thought it is, great. And I'll show you the picture. And I thought this was amazing what ChatGPT came back with. It basically looks similar like this. If you have seen the previous picture, not quite, but I like the way of the houses, the mountain and stuff. My little daughter, she asked me then, when she saw this, that how does ChatGPT know that you have so many monitors at home? And I'm like, I don't know. I mean, maybe it's it's a bias of developers. I don't know, but it's really interesting. It has a lot of dashboards on the screens and stuff. So I thought this was really great. But anyhow, let's get into the topic. What is distributed tracing? And just to set the scene for the talk for today, when we talk about tracing, we typically also talk about other telemetry. We typically have traces, metrics, and logs. I'll cover traces in more detail in a second. Metrics is, of course, something where you want to measure the average CPU of your host or the memory, the throughput, and so on. So it's typically pre-aggregated data on some kind of data that you are interested in. Logs, if we are all developers, so everyone has written some kind of log from his or their applications. So this is just a record of an event and a series of inputs. But what is really tracing? Distributed tracing in detail. So imagine we have these three services, service A, B, and C. They talk to each other through various kinds of protocols, HTTP or gRPC. And then, of course, you can then measure each of these services individually. How long did it take to execute a certain task or a certain request? But ideally, you want to measure the entire trace. And this is end to end from the very beginning to the very end of this request. And there could be databases involved in other systems, right? And so just to set the scene here, the entire thing here that is from end to end, from A to B and C, is called a trace, and these subsections are then called spans. But how does it work behind the scenes, right? So basically what happens is that when you use distributed tracing, there will be some form of trace context, some header information injected into these requests. So imagine from in this scenario, service A calling service B, there will typically be a so-called trace context injected as a parameter to the header. And this is a standardized request. It's based on the W3C standard, this trace context. So this will be injected from service A, and service B will then look for some trace context like this. If it finds it, it will go ahead and continue the trace. If it doesn't find it, it will start to create a new trace from this point on. And then same for, gRPC, and this is a way of how you can track an entire request all the way from the beginning to the end. But how is distributed tracing for event-based or Kafka-based systems different? You still have, the communication, in this case, gRPC from service B to service C. And we learned that, the trace context is injected in this request. But what happens, and then you can still trace all of the single requests. But what happens, like in this case, where you have some kind of event-based system, some Kafka broker in between, where service A not talks to service B directly, but it basically publishes a message into Kafka. Service B subscribes to a topic in Kafka and then consumes this message whenever it has time to pick up a message, right? So this is typically an asynchronous process. They're decoupled. They are not directly depending on each other. But how does it work for, things like Kafka systems where you not have like this direct call? Basically, the answer is it is very similar to other protocols like HTTP or gRPC. Service A, in this case, will typically also inject some form of header into or as part of the message. So as part of the metadata of the message, it will inject something into the message, and then service B will look for this, again, this trace context as part of the message. And then if it finds it, it will, continue the trace on. And if it, doesn't find it again, it will start a new trace. So basically, this is the concept behind, distributed tracing. You want to understand what is happening all the way from the beginning to the end, including also these event-based systems like Kafka. And this brings me to the topic of OpenTelemetry. OpenTelemetry basically does exactly that. It covers traces, but it also covers metrics and logs. It basically is a CNCF project these days. It was formed through a merger of OpenTracing, which was just focusing on the tracing aspects, and OpenCensus, which was just focusing on the metrics piece. And OpenTelemetry is kind of like really this open standard that tries to combine all the different telemetry types from your applications, from your infrastructure, from your services into a single standard, so that everyone who wants to participate and add some telemetry to a system can rely on this open standard, and then make sure that if I'm relying to the specification and the specs of the protocol that OpenTelemetry uses, I can make sure that I can produce data and I can consume data from OpenTelemetry protocol in a standardized fashion. At New Relic, we also have built some proprietary agents which worked pretty similar, and this was kind of like the initial rise of application performance monitoring. But really, OpenTelemetry, the nice thing is about this is vendor neutral. It's an open source project. Many big vendors are participating and contributing to this open source project. The likes of Microsoft, AWS, Google. We at New Relic, we also highly participate in this project. And so it is really a nice, collaborative environment, and, really engaging. And this is what I really like about this. Like I mentioned, I'm, part of many different developer communities. And really open standards and open source is really the key going forward. What's also nice about OpenTelemetry is that it brings this OpenTelemetry collector, where you can see here on the left-hand side, you are able to inject, or the OpenTelemetry collector can receive data from various sources. This could be any applications written in various languages: .NET, Java, Go, Ruby, Python, and then you can attach a so-called agent on top of your applications, and this will then send the data into this pipeline. You can also, use any kind of data from public hyperscalers like AWS or Microsoft Azure, other sources, Prometheus data, where you can also configure these sources to be able to send data into this pipeline. And again, this could be metrics, this could be traces or logs. What's nice about this as well is that it also comes with a component to process the data. And processing the data, especially, we are here in Europe, is very important because maybe you have captured some data that you are not allowed to store in any kind of backend. Maybe you accidentally, configured some environment to send in data that you don't want to use. An example of this could be, some developer enabled some debug logs, which could be nice for testing and, development, but definitely not in production where it produces a lot of data. So this processing, basically allows you to decorate, to batch, to encrypt some form of data. Imagine you also have, some credit card information in, as part of your logs. You can then, encrypt or decorate this data, hash it, or, do some form of dropping on that data before it is getting exported to some other system. This exporting process typically is for long-term, storage, visibility, analysis, and you can export this to a, full observability platform like New Relic or any other observability platform, or you can use open source tooling, right? You can use Jaeger for tracing, for example, to send your traces into Jaeger. You can use some systems for logs, for metrics. You have full control over what happens with all of the data that you're collecting. This is also really nice. You can then send this to a backend to have some long-term storage and visibility and observability of your systems. So the question then is, hey, let's all jump into OpenTelemetry, but hey, wait a second, because there are some design considerations and guidelines. And this is also one of the things that I'll be showing in a second in my live demo. Typically, OpenTelemetry comes with a concept of a so-called zero code or auto instrumentation. And this is really the aspect of, and I like this analogy. If I want to, eat a cake, I can go to a bakery and, buy a ready, finished cake. The caveat is that, I may have only, small amounts of adjustments that I can make. Definitely, the ingredients, whatever got into the cake, that, there's, not many things that you can change and control. But the nice thing is I don't have to, buy all the ingredients. I don't have to have an oven and cook my cake and stuff like that. So it's pre-built, it's pre-packaged and ready for me to eat. On the other hand, OpenTelemetry also has this concept of, manual instrumentation, or you can customize everything. And this is really where, if I want to have full control over all the ingredients that get into my, cake in this analogy, for example, if you have like some peanut allergy, you won't put any peanut into your cake, right? So you have full control. You can, buy all the ingredients. You can customize it. And similar to that, OpenTelemetry also allows you to have very detailed control over what's happening inside of your, instrumentation or telemetry configuration. The support of OpenTelemetry is really great. I always encourage people to go into the OpenTelemetry docs. They are really detailed, very great, and very up to date. I took a couple screenshots here. This is from 2023, and you can see on the right-hand side the status and the maturity of the different language support. There's things like C++ and C# and Java, Rust. And you can see for each of the different telemetry types, traces, metrics, and logs, it has different kind of support and maturity. Whenever, OpenTelemetry or the project defines something as stable, this means that you can use it in production. It is, safe for you to use. And then I took the screenshot quite often, in the later times, and you can see this is the latest one that I took in January this year, where it is really maturing. It is constantly evolving. And so whenever you see new development happening, this is really, getting to a stable state in all of the different telemetry types. And, the future of this will probably all be stable in all of the different languages being supported. But I encourage you, if you're using some form of language, go into the OpenTelemetry docs and have a look into what is the current support status and the maturity of the different languages. This also is, valid for, all the libraries that you're using. And this is just an example for Java. You can look at the details here, and I can, share the slides afterwards. But basically, the same is true for all the different libraries and frameworks. since this is an open standard, OpenTelemetry, and everyone is contributing, everyone is relying on the same, semantics and conventions and the protocol, you as a, or the people who are contributing to these libraries and frameworks, they can also rely on this standard. And this is basically what happens here. All of these different libraries, and this is really just a snapshot. You can see in which version is already supported with OpenTelemetry, and so on, and what is the level of support? Is it tracing, metrics, and logs? And of course, also for the example that I'm using here, Apache Kafka, this is already also supported, based on version 0.11 and later. So again, I highly encourage you, if you're using any of these frameworks or libraries, go into the docs and see, is this already supported? If not, there may be some ways in how you can do some manual or customization around it. But if it is already supported, you can rely on the standard to be also working quite fine for your environment. So let's get into the fun stuff. I have an example here, and you can see the high-level architecture of this on this map. So I have a Java application which has a producer. It has a consumer, and of course, I'm using Kafka in between. So the producer, sends in data into Kafka. The consumer subscribes to a topic and then reads from it. And then I have also some downstream services here, like this Kafka Java service, which runs on some infrastructure. And I also have an external library here, JSONplaceholder.com, that I'm using just to show what type of visibility do you get for services that are not in your control, right? So in my case, the producer, the consumer, and the downstream service, they are in my control. I have developed them, and I have full control over the ways on how I want to monitor them. But for this one here, I may be only able to see the outside perspective. It's kind of like a black box for me. I cannot install any agent or anything. So this is kind of like the first step. I want to use automatic instrumentation. And if you remember the cake from the beginning, we are using the ready-baked cake and get started with automatic instrumentation with Java. I provided some links to the docs here as well. But without further ado, let me jump into the code. Let's see if there's any questions here. Okay, so this is from Stephen. Okay, great. Let me get into my Visual Studio Code environment here. So again, I mentioned it. I have this sample application here. I can also share the link to my GitHub repository in a second. I have a folder here for the consumer, the producer, and this downstream service. If we look into the producer, this is a plain Java Spring Boot application, nothing fancy. And I used also the Spring Boot starter app to get all the Kafka configuration in place. So in this case, if I jump into the producer here, you can see there's a producer factory that I'm using with some configuration here, and so on and so forth. In order to spin up the application, I have this run script. And in general, my run script would basically look like this, where I only have the Maven wrapper that I'm using to start my Spring Boot application. But you've seen it already. I added some additional configuration in here. So first of all, I added in a couple of different environment variables here. The first one is the Java tool options. And this is where I'm using the -Java agent configuration option to point it to my local version of the OpenTelemetry Java agent. This is a jar file, the OpenTelemetry Java agent that you can download from the GitHub, the official GitHub. I placed it into one folder here on my machine. And this way I can tell the JVM at startup time, please use this Java agent, and here's the location of the jar file. I can then also define some configurations for the different telemetry that I want to capture, the traces, the metrics, and the logs. And in this case, what I'm configuring here is to export all of the different telemetries into OTLP format. So this means basically that OpenTelemetry line protocol, this is what OTLP stands for. I want to expose all of them and send them to an OpenTelemetry exporter. Remember this pipeline that I shared at the beginning in the slides, where we have the receiver, the processor, and the exporter. This is where I can configure, what do I want to do with all the different telemetry. I could also, do something like this, where I say, hey, for the traces, please output them into the console. But this is not really fun to look at traces in the console, and so that's why I'm using OTLP to send them into the OpenTelemetry line protocol. The second step is then, I want to configure the OTel exporter OTLP endpoint. And by the way, all of these environment variables come with OpenTelemetry. These are standardized. You can use them in many different environments. And what I'm doing here is I'm pointing this to our New Relic OTLP native endpoint. If you're using, other forms of backends like Jaeger for traces, you could then say, for my traces, I want to send them into your Jaeger environment, for example. Since this is an open API endpoint, I also have to configure a OTel exporter OTLP headers configuration. And this is basically the API key to use for this endpoint. In our case, this is our New Relic license key that we're using. And then finally, I configure this also to use a certain name. So in this case, I'm looking at the consumer here, and I'm telling the OTel service name to be Kafka Java Producer as a name. And that is basically it. I'm never, I don't need to change my source code. I don't need to add any libraries to my application. This is really the only changes that I have to make in order to get OpenTelemetry up and running for my Java service here. And I did a similar thing for the consumer and the producer here as well. So let's get these up and running. You can see I have various different terminals here. I have one for the producer, and I just, kick off the run script. And I have a Kafka broker running here as well on my Mac. So everything that I'm showing here is running locally here on my machine. You can see this is getting up and running, and it's already started up. And then the same for the demo service and the consumer. So all of these should be up and running in a couple of seconds. There you go. This should also be up and running. What I didn't do is I didn't provide any user interface for this application. What I'm doing here is the producer just exposes a REST API endpoint, again, based on pure Java Spring Boot. And what I'm doing here is I'm using the VS Code extension for REST. If you haven't seen this, I highly encourage you to use this. What I can do here is I can just specify a .http file, and then I can say I want to have a post request to my local host 8080. This is the port of my producer. I have a /orders endpoint, and then I can send in some JSON data here. So in this case, I'm sending in just some sample JSON, the customer ID and order ID, date of creation, and some content. This is really just some basic stuff. And then you can see this here. I can click on the send request button. This comes with the VS Code extension for REST client. I can send this, and you can see I got a response back, HTTP 200. This is the length and so on. And you can also see here down in the terminal that there was some things happening. So what happened is, the producer received the request, sent the data into Kafka. The consumer then received the data and then, made some calls to the downstream service, as we have seen on the high-level architecture. So this seems, to be working just fine. And what I then also did is, from the consumer, then I sent another request back over Kafka to the producer. And this is then where I see downstream here, I can see I received some user information back. So nice. This all seems to be working fine. I can send in some, additional requests here and click on this a couple more times. And what happens now is that, all of the telemetry that we have captured is, sent to my New Relic backend that we have configured. And if I then jump into my New Relic environment here, so I can, this is my personal sandbox here that I'm using. Again, this works exactly the same for any other observability backend or open source project. For me, I go into the all entities section, and in here I see, some OpenTelemetry services that I have up and running, including these. Let me make this a little bigger, including the Kafka consumer, producer, and the downstream service. If I then, jump into the producer side of things, this is the typical, view that we provide for, services where we show the most important information. In my case, I want to jump directly into the distributed tracing section. And I can see there are already some distributed traces coming in. This view here, the scatter chart, will show me then, across like the last, 30 minutes. Of course, I can change the time window. I can then see, in the last 30 minutes, for now, I have seen one request coming in. If I refresh the screen, we should see some more requests because I sent in a couple more orders. This will take, maybe it is close to real time, but there is some post-processing. But you can see one of these requests already made it in here. I can see what is the, the span duration, how many entities were involved, how many spans did we create, and did we see any errors. So if I then click into this single request, this is one trace ID that we captured. You can see in total, this took 8.4 seconds, which is quite long. What we typically try to show up here is kind of like a map like this, where we try to visualize how does this trace look like, what services, what entities were involved. And you can see from the Kafka producer, we have seen one call to the, it's not a call because, as you remember, there's Kafka in between, right? But there was one request through the consumer. Then I see two calls basically to the downstream service and one call to the JSONplaceholder.com. So this is nice. I can also, look at one timeline like this. This is typically a typical representation of traces in also, tools like Jaeger, for example, where I can see out of these 8.4 seconds, how does this break down into the various sub sections and sub calls? You can see here at the beginning, the different coloring, and this represents the different services, the different entities that were involved in this entire trace. And at the bottom, this is then where we see how does it break down into the different subsections. The 8.4 seconds, I can see the majority of the time was actually spent in the Kafka consumer. It simply by looking at the screen, I can tell where in this entire trace was the time spent. Where do I lose some time? If I then expand these sections, I can see some further details here. In the consumer, I mentioned it, I'm making two different calls to the downstream service. We'll get into this, why I did this and what the purpose of this is. But basically, I can see the first request from my Kafka consumer to the downstream service, and then the second one, and so on and so forth. So this is great. I already see a lot of data. I have a lot of visualization. And the amount of effort it took me to get this up and running, to configure this with OpenTelemetry was really, only maybe a couple minutes, right? But I get so much detailed information already without, doing a lot of magic and configuration in my application. I don't need to add any dependencies or packages. Just by attaching the OpenTelemetry Java agent, I get a lot of detailed information already. Of course, I can then also click into any of these spans to see some further details like performance information just for this specific span. I have a lot of attributes that we are seeing, like the duration of this specific span, some GUID, some architecture information, things like the host where this ran on, and so on and so forth. So a lot of detailed information that I can be using to capture some details. What's also nice about this is, just by configuring the OpenTelemetry Java agent, I also have direct correlation to all the logs that were captured. What happens here is with just one click here, I can get into the logs for this entire trace across all my different services. And so all of these logs are coming from all the services, the producer, the consumer, the downstream service that were part of this entire trace. Again, we're looking at one single trace here, and I can then see all the logs for this entire trace. Again, this is something that OpenTelemetry does out of the box. If I click into any of these log lines, you can see, this is the raw log data that we are capturing. And then down here at the bottom, you see that as part of this log message, we also see the trace ID. And this is how, this kind of like magic happens to make this correlation between the traces and the logs that were captured. And OpenTelemetry basically also injects this trace ID into the logs. And this way I can then visualize this in a meaningful way. So you may have seen, and now we also received some additional traces here in this section. There was one thing that I wanted to bring to your attention. You may have seen this already. If I expand this section here, there's one specific span as part of this trace that looks a little strange. And we also try to highlight this in this user interface. There's one section that says uninstrumented time. And for this trace, which took in total like 45 seconds, and you can see here also in this view, you can see a huge block of blank in here. This is kind of like the time between the producer producing the message and the consumer, at some point later in the process, consuming the message. So this is referred to as the consumer lag. And basically, it took a long time where nothing happened. The message was just sitting in Kafka, waiting for the consumer to pick up the message. But once it picked up the message, and let me expand this again, it took 3 seconds for the consumer to do some processing here. And again, this is mentioned or referred to as uninstrumented time, because what happens here is that the OpenTelemetry Java agent only goes so deep into the instrumentation. This is for performance reasons, for optimizing the agent. So I have no idea on why and where the consumer spent 3 seconds of time processing this message. And this also, is something that I wanted to highlight here. The automatic instrumentation, which is nice to get up and running quickly, it has some caveats that it only gives you detailed visibility into your applications that go so far deep into your services. So there's always some pros and cons. I was able to get up and running quickly, but I have no idea what is happening in this part of my consumer, I'm sorry. Great. So I have all of this information also as part of the slides. So now let's actually get into some manual instrumentation with Java. Again, I have the QR code here that brings you into the docs for the different languages on how to get started with OpenTelemetry manual instrumentation. But let us go through this again in the example that I have prepared here. Let me close out all the sections here, and let me stop all the different services. So the producer, the downstream service, and the consumer. And so what I did here is I have various different folders here for auto instrumentation. There's also some hybrid aspects. Maybe we can get into this as well. But what I want to do... Oh, yes.
Sorry to interrupt you. Maybe this is a good place to just stop, because Miriam asked a question and I wrote a very similar question. So she said in the chat, does New Relic also provide functionality and not solely a user interface? If yes, can you please specify what part here is OpenTelemetry and what part is New Relic? Yeah, so
Yes.
I also wrote down, I understood New Relic as kind of an UI that shows the data it got from the OpenTelemetry, which is doing the main data gathering. Is this understanding correct, or what am I missing?
Yes, and I didn't want to go too deep into like New Relic platform because I want to keep it more on the open source and OpenTelemetry project. But basically, yes. So what we do is we just send in the raw OpenTelemetry data into our OpenTelemetry endpoint. And what we do then is we try to summarize the data. We try to visualize it in a meaningful way. What I didn't show as part of this is we come with some curated information on what, I mean, if I have no idea about what is it that I should be looking at, like is it traces or metrics, and is there something going on? We provide some user interface that highlights the most important things that you should be looking at. This is things like typically response time, the throughput, the error rate, and so on. So we try to have an opinion about what is it that you should be looking at. Of course, there's many different other things that we also show. We have some sections on errors or exceptions that are occurring, and we have some nice way on grouping and filtering and providing some details around this. We could go into the alerting, some baselining and all of these aspects. We have some anomaly detection that you may have seen also as part of the distributed tracing. I mean, there's loads to cover from what is it that New Relic provides on top of it. What I did in this little sample application is just using pure 100% OpenTelemetry. And you could use any other backend to see what output you can get out of sending the data. And like I mentioned, there is a couple things where we try to make the analysis of the data that you're sending easy and easily observable for your services. Like, for example, I mentioned anomaly detection. This is a section where you could say, tell it, just show me some anomalous spans, things that are unnormal, some outliers. If everything runs fine, but there's a couple traces that are outside the norm, how can I analyze them? How can I visualize them? And this is all things that we cover as well on top of OpenTelemetry, which is also not part of the OpenTelemetry project. Typically, you would use some form of analysis engine, like I mentioned, Jaeger for traces. But we also try to combine the different telemetry types together. Like we've looked at the traces connecting to the logs and so on. We also try to, for this producer, for example, we have a section for the Kafka specific metrics. These are then metrics where you can focus on the producer side of things, where you can see from a more infrastructure perspective, how many messages did we see, and so on and so forth. How long did it take? What is the average message size, and so on. And these are all important things if you run this application in production, to make sure that you understand what is happening, what is going on. And so, I was rambling quite a bit. I'm not sure if this answers the question, but yeah, there's a lot of things on top of just receiving and the data from OpenTelemetry, and then working to visualize it in a meaningful way. So, and by the way, if you have other questions like these, it's hard for me to look at the chat in parallel. So please just stop me, and I'm happy to answer any questions anytime. All right. So we looked at the auto instrumentation, which was quick for us to get up and running. We just looked at the run script that I prepared to show how to attach the Java agent and configure it properly to send in the data to a backend. So let's now look into how does it look like for the manual instrumentation. Again, if you remember the cake analogy, now we want to bake our own cake. We have have all our ingredients, and we can put this into the oven, if you will. So again, in this section, what I did here is if I look at the run script again, this is now just using the plain Maven wrapper Spring Boot run command to spin up the application. What I did for this application, I have a section in the application properties now where I configure similar things that we have previously configured in the run script. But now I have some configuration items where I'm able to configure the again the OTLP endpoint. I'm sending the data to my Neuralink OTLP endpoint. Again, since this is an open endpoint or API endpoint, I'm using an API key, in this case the license key. But I have some additional configurations, like for example, do I want to capture some application server specific metrics? Do I want to capture some Kafka broker metrics, and so on and so forth? So I have way more control over what details I want to capture. By the way, these are all also possible using environment variables in the auto instrumentation, but just for the sake of it, I configured this. This is probably not something you want to configure, the Java debug option to be true, but just for the sake of this, I'm showing how this will look like. So then if we just configured the application properties, right? But how does it actually work with some manual instrumentation? You may have guessed in the POM XML that I'm using here for my Java Spring Boot service, I did now add a lot of dependencies to my application. So I'm adding a lot of OpenTelemetry packages and libraries because I need to use them in my Java code to instrument my application in a proper way that makes sense for me and my use case that I'm trying to solve here. So I'm using the OpenTelemetry APIs, I'm having OpenTelemetry SDKs, exporters for logging, for OTLP, semantic conventions. This is also a really nice aspect, which we'll get into a second. There is specific libraries also for Kafka-specific instrumentation. Of course, now that I'm doing everything manually, I have full control, but I have to do also some things that the auto instrumentation did for me. So this is already something, I have to have some dependencies as part of my application because I'm using some SDKs from OpenTelemetry. If we then look at the demo producer application, this is the Spring Boot application that you can see here. I am then reading in these properties that we're looking at, and then I'm defining a OpenTelemetry specific bean for this section here. And now that I've done that, I can then also create specific tracers for providers for the traces, for the metrics, and for the logs in here.
Harry, sorry, let's wait a second. Yes, okay. Now the screen share is here for this class.
Okay, perfect. So let me go back here. So what I'm defining here is an OpenTelemetry bean as part of my application, and then I can again configure the name of the service, and you can see here this is already deprecated, so it is constantly, of course, evolving. Maybe I need to update my dependencies here, but basically what I'm doing here is I'm configuring some tracers, some providers for the traces, the metrics, and the logs. And then I configure OpenTelemetry to use all these providers then, and do some exporting of the telemetry that we're capturing. Again, covering traces, metrics, and logs. For the Kafka intersection, for the since we're looking at the producer, for the producer factory, there's also a specific configuration. This is how I can configure how I want to interact with my Kafka broker, what is the name of the topic, and so on and so forth. What I'm doing here is I also need to add a section in order to intercept the requests. Remember the distributed tracing view for the event-based systems that I showed on the screen earlier? This is now what actually adds the W3C trace context to the message on the producing side. And there's a similar concept also on the consumer. If I just open this specific section here, on the consumer config, there is a tracing consumer interceptor. So this way, I don't need to do this manually. I don't need to look for this W3C trace context manually and extracting it from the consumer or injecting it on the producer side. This package actually does the magic for me. But I do have to configure it properly so that I can rely on this configuration. I also had a question previously where the question was, if I'm only interested in the producing side and the consumer is not really of interest for the tracing perspective, I could remove this section here, and then I would not get any tracing information from the consumer onwards. So also some nice aspect, since I'm having full control over what is happening now in my application. So basically, let's spin up this application as well. So I'm running the producer, the consumer, or the downstream service and the consumer. These should be up and running quickly. And then I can also, again, add in some orders here. So this should be up and running. So now if I send in a post request to my producer, we should see some activity happening here. Let's add in some additional requests so that we have a lot of data to look at. Again, the application itself is exactly the same, but of course I added some manual instrumentation, which we are able to look into in a second. So the configuration is a little different. It is a little bit more work that I have to put in, but we'll see in a second when we look at the result of this, how this adds value to my visibility into my application. So again, going back into my Kafka producer, I can again go into the distributed tracing section. It shouldn't take long before we see some new traces coming in. Let me refresh this to speed this up.
While we are waiting for those events to come in, Bernard asked another question in the chat regarding the auto instrumentation case. So he basically set this up, but he saw something, but I could not see any end-to-end spans traversing through the cluster. Is that expected, or did I miss something wrong?
So I think, and maybe you can correct me, is he referring to this specific view?
Maybe if I can jump in myself, if that's okay.
Yeah, for sure.
I tried to make my life easy and use Kafka CLI consumer and producer, and just use the Java args to throw in the auto instrumentation jar. And I'm seeing something. If I look in, I'm using Jagger. I see some headers, but I don't see any end-to-end spans really. And now I'm wondering if that's expected simply because the Kafka CLI consumer and producer are so simple that nothing will happen there, or if I did something wrong.
It is very much possible, and I'm not. I don't have too much information about the CLI specifically, but I'm assuming that the CLI on the producer side does not actually initiate a trace when it sends in the message from the producer, and the consumer also not, since there is no information, no end-to-end visibility is possible. I assume that this is the case, maybe worth looking into it, but I guess what is missing is the piece of the trace context injected into the message as a metadata from the CLI on the producer side. And I think this piece may be missing. But again, I'm not an expert in the CLI.
I get your point, but then I would raise the question again, how is that different when I just use a simple Spring Boot Kafka producer that is not instrumented manually, but auto-instrumented? Where's the difference then?
So, okay, yeah, good question. So what I showed here previously, so what I did here in the consumer factory, this is where I told the consumer factory to, use the interceptor here to look for this trace context specifically on the consumer side. If I remove this, I would have pretty much the similar view that you have with the CLI. The auto instrumentation does that automatically for me because the library that I'm using for Kafka is already fully supported using OpenTelemetry.
Okay, so that's the point. So Spring Boot basically is able to auto-instrument, and probably the plain Kafka CLI class that is used is not able to do that. So that's basically what you're saying, right?
That's basically, yes. And this is why I mentioned
see.
this here specifically, right? The Apache Kafka producer and consumer APIs, this library in Java that I'm using is already supported using OpenTelemetry. So whenever this library injects something into Kafka, it will add automatically this trace context to the message, and the consumer will look for this trace context. And the CLI is probably, again, I'm not an expert, but I assume that this is the case. It is probably not injecting this or not supported yet.
Yeah, I think you're right. I think it's just calling the class, like the internal Java, so it's not going via API. Okay, thank you. That was very insightful. Thanks.
Yeah, my pleasure. Thank you. All right. So by now we should have received some new traces from the manual instrumentation. Not yet. Okay, so some kind of failed to export spans. That is interesting. You can see this is a live demo. Let me troubleshoot this.
Always happening something,
It's
right?
always happening, yeah. So let me start up this again. All right, so let's send in a couple more requests here. Some error again. Not sure what is happening. So don't worry, you'll see my license key in a second, but I'll delete this after the session anyways. So let me quickly adjust this, and hopefully this should be up and running again. Thought I configured it properly, also for the demo service. Yeah, maybe this key expired. Let's try it one more time. Oops. Run script. So I sent in a couple more requests. And by the way, is anyone using this REST extension for VS Code? Just curious. Because I really like the concept of having a file that I can use to configure these. So now
It's
I
really interesting. I'm an IntelliJ
IntelliJ
IDEA fanboy. Yeah.
okay.
and it uses the same. It has the same. It's HTTP client in IntelliJ.
All right. So this seems to hopefully has worked. I don't get any error message back. So let's jump back into my New Relic account. So basically, I mentioned it earlier, this is close to real time. And whenever you start up an application, it can take a minute. But basically what happens behind the scenes is we also use very much a lot of Kafka clusters, Kafka brokers behind the scenes. So whenever you send the data to our OTLP endpoint, there's basically also like a chain of Kafka clusters. We do some post-processing on the data, create some additional metrics and so on based on the data. And that's why I'm always referring to it as close to real time, but it takes a couple of milliseconds. Okay, so now we see a trace. So, and if I expand the time window a little bit, you can see the naming has changed here already. So previously, when we did the auto instrumentation, we saw this posts on the /orders endpoint on the producer. So now I see a trace that is referred to as send create order event to my producer. Let's excuse me. Let's jump into this. So again, the view looks pretty similar. I have my producer. I'm making a call to the consumer. From the consumer, I'm calling the Kafka service, and you can see previously I had 2 calls here from the consumer to this downstream service. Now I only see 1. I'll get to why this is the case in a second. But the rest of the view looks pretty similar. We can also look at the timeline again. This specific trace that we're looking at took like almost 8 seconds. Again, we see a big lag here on the consumer. So whenever the producer produced the message, this was pretty quick, but then it took a long time for the consumer to pick up this message. And once it picked it up, it had some huge chunk of code or execution time where it spent some time. The rest of the UI on our end looks very much the same. So we don't differentiate whether it's using auto or manual instrumentation. And again, if you would use Jaeger, it would be very similar. So I can then expand into the details of this specific trace and look also into the consumer. So now again, we see the consumer side. We see one request to the demo service, to the downstream service. One of them, and this is one of the first differences, also in the high-level map that we have seen, we only seen 1 request to the demo service. And this is on purpose. I'll show you in a second why this is the case. So for the first one, we see the additional span or the trace continuing into the demo service. For the second one, we do not see this. And this is one of interesting aspect. Another one is that I can now, on the consumer side, there's a section that refers to as show in-process spans. And there seems to be 6 spans as part of this. If I expand this, now we can see where we have previously seen the uninstrumented time. Now we see some execute long-running task. I see a span here that is called why the heck do we sleep here? And some tiny task and some other short running task. So previously we have seen this, chunk of execution time as a single block, uninstrumented time, no further visibility. Now I see a lot more detailed information about what is happening in my code. And I can then see, the majority of the time seems to be spent in the span called why the heck do we sleep here? And of course, you can imagine I'm putting a thread.sleep in the request just to show some details here. But now I see a lot more details in this section. If I click into this span, again, I also see some attributes here. And one of the things you'll also notice here is that I have an attribute here called seconds to sleep. So this is a custom attribute that I added into this request, where I'm just specifying what is the time, the parameter that I'm using for this method, on how long it should run into the sleep thread. So some interesting aspect. Let's have a look into how this is actually configured. Or were there any questions? I just heard some noise. No? Okay.
Nope, everything all right.
Okay, perfect. So let's jump into the consumer and into the Kafka listener here. So on the consumer side, I'm using the plain Kafka listener component here from Spring Boot. This is the method that actually gets triggered whenever a new message is received into Kafka and the consumer picked up the message. So now the first thing that we'll notice here is that I'm configuring a span in here, which is using the tracer that we have configured in the Spring Boot application context. And in here, I can then create a dedicated span name for this. We have seen this in the relic view, where we have seen the create order listener. On the auto instrumentation case, this is the post/orders endpoint span, which is created by default. But now I'm renaming this to create order listener. Then I'm making this the current span, and then I'm setting some custom attributes. I'll get to this in a second. And then I'm making some additional configuration here. I'm executing the execute long-running task. And again, here, what I'm doing here is I'm adding all these span configurations in here, execute long-running task. I then have a sub-span that I'm creating here, which is part of the above span here. Why the heck do we sleep here? So this way you have much more control over what is happening inside of your application. I can configure as many spans here manually as I want to. And you also notice that this custom attribute that we have seen as part of the visualization of this span, I can then easily add some additional attributes. So in this case, I'm adding this key called seconds to sleep, and then I'm adding just the parameter here. So really nice information for me to capture. So now I could, look at all the different spans and maybe do an average on the wait time or the whatever it is that I'm, configuring here. But I do have full control over what is happening here and all the maybe additional parameters that I want to capture. This is important for the technical aspects of, analyzing your application at runtime in production, for maybe some additional context. The reason I added in these two aspects here at the top, where you can see from the order message that I created on the producer side, I'm extracting the customer ID and the order ID. This is probably not something you would do, one-to-one in a real life scenario. Maybe you would hash the user ID, or maybe you have some other, more anonymized functions here. But basically, the concept is here that I can add in some attributes that help me troubleshoot whenever I have some issues. Imagine you have some in a given time window, let's imagine the last hour, you have seen 100 exceptions occurring in your application. How do you know that these 100 exceptions coming from all your users, so maybe one exception per 100 users, or whether or not a single user has seen 100 exceptions itself, right? So in this way, you could easily, analyze and, look at the information from your analysis engine and tell, hey, what is the impact of an issue? How many users are affected and things like that. And by the way, these attributes, there's also a so-called semantic convention as part of OpenTelemetry. So if I quickly jump into the OpenTelemetry docs, you will notice that there's a lot of these semantic conventions. One of them is, for example, the user ID. So it also, OpenTelemetry comes with an opinion on how should we all align on these semantics, right? So for example, for the user attributes, these are the standardized ways on how you should name these in your application if you add these custom attributes as part of your instrumentation. So in this, you may have noticed, this has recently changed. It previously was called enduser.id. But basically, this is an easy way for me to track additional information as part of my instrumentation here. Any questions on this so far? Is there anything in the chat that I'm missing?
No, just the link provided from Christian. Thanks, Christian. So maybe just a quick question. I would have asked it at the very end. So this seems like lots of code that is only related to the tracing situation. Do you add this kind of code from the beginning when you're writing the production code, or is this something that you only update into the code when you are trying to understand some situation?
So it may depend a little bit, right? I'm also very much a big fan of, pragmatic approaches. So I would maybe start without, thinking about what is it that we need and how much information should we add. I would maybe, if I'm starting from scratch, I would maybe start from the auto instrumentation, not adding additional information in here, but maybe over time you'll identify areas within your applications, within your services where you have seen some issues. Things like, maybe the typical scenario is also maybe a retail scenario, maybe like users putting things into your cart, adding in some product ID or some product category ID as part of this is probably a good idea to have from the very beginning, because this really helps you further down the line, not only from a technical perspective, so monitoring all your exceptions and issues, so the false or the error scenario, but it also could help you from a business observability perspective. So because this is all basically real-time information from your application, you could also create a dashboard that shows, across all my orders that I have received, how does it break down into the different product categories or things like that. Customers or accounts probably have all of this information in some form of BI information already. But the nice thing is, this is coming from the real production live application, one-to-one. You don't have to wait for any analysis to kick in and stuff like that. So it has some benefits, but like I said, I'm a big fan of being pragmatic, starting simple and maybe not over-engineering things, but areas where these could be problematic in the future or could add value from that perspective, I would probably go ahead and add in some information that you think would definitely make sense in the future. I don't know if this answers your question.
Yes, thanks.
There is, just to mention it, this is just one way to do it, like adding this as like code into my application. I could also do something like this, where I'm adding like with span, for example, and I can then remove this part. So there's also annotations in place that I could use. OpenTelemetry comes with a lot of different options that you can use as part of your application. I could also, for these parameters, I could say something like with parameter. I think that is the correct term. So in this way, I would also capture this parameter for this specific method as part of this span that will be created. So there are some different options that you can choose depending upon your preference, depending upon your preference in writing code or using your applications already. So I mentioned it already. There is also, of course, a lot of additional information now. So this then helps me get more visibility into my service. I now have a good understanding where's the time spent. If this would be, some further processing, I can add some additional task. Now, in my case, I know I'm just sleeping here, so I know why it is slow. But the point that I wanted to make is you have, maybe some pre-work to do. You have to add some dependencies to your application. You have to add some custom code, but you have, on the other hand, some way more visibility into your application. So it's always like a pros and cons that you have to look at. There is, I showed it quickly also briefly, there is also like the some metrics that we have received, and these are also pure OpenTelemetry metrics for the producer and the consumer side. We looked into this already, where we then have information about from within my application. So in this case, the producer is also a consumer. Since I'm sending a message back from the consumer to the producer, it also has a consumer aspect. So I have a lot of detailed information. I can analyze this. I have this all hopefully in context to your application data. What's also nice, and this is something that I didn't provide here in this scenario on my local machine, OpenTelemetry also comes with a lot of pre-built receivers that you can use. If you remember this picture from the beginning, where you have this OpenTelemetry collector typically in place, you can also add in some additional receiving aspects. So for example, if I'm OpenTelemetry collector. So this is the GitHub repository for the OpenTelemetry collector contributors aspect. And you can see, let me also make this a little bigger. There's a lot of receivers in place already from various different sources that you can use. If you're using Active Directory, if you're using some AWS services and so on. And of course, also from a Kafka perspective, there's also a so-called Kafka metrics receiver. And there's two different options here that you can use. Basically, the point that I want to make here is the type of metrics that we looked at here. These are very application-centric metrics, so from the producer and the consumer aspect. But if I want to capture additional metrics from the Kafka broker itself, from the more infrastructure side of things, so how many brokers do you have up and running? How many topics, partitions, the consumer groups, and so on. So these are very Kafka-specific metrics. I can set up a so-called scraper that will scrape some data from my Kafka broker, and I can also send this via OpenTelemetry collector pipeline into my OpenTelemetry backend of choice, and I can visualize this information as part of the data that I'm capturing. The purpose here is that I can then correlate the information from my applications and my infrastructure to see in case my application is slow, is it the applications? Is it maybe the infrastructure that runs my applications that is slow because it is at high CPU, high memory load whatsoever, or is it the underlying infrastructure of my Kafka broker that has an issue? So there's always various aspects that are important to notice here. There's also, just to mention, if you're using, Kafka on-prem, like you're deploying your own Kafka, you of course have, this Kafka receiver. But what if you have a, for example, if you're using Confluent in this example, and there's also a Confluent receiver that you can use. Cannot find it. Here you go. I'll send this offline. So there's also ways on how you can use or scrape metrics from your SaaS services that you're using, like, for example, Confluent, to also capture data from these services. So very detailed information that you can capture. Let me jump back into the slides, whether I'm missing anything. So like I mentioned, I have everything documented here in my slide deck. I can happy to share this. I have other event-based systems like Azure Event Hub, Google PubSub, RabbitMQ, and so on. In summary, I quickly wanted to mention that OpenTelemetry is here to stay. If you haven't looked into it, I highly encourage you to look into OpenTelemetry. The collector is a very useful tool to collect your telemetry, your metrics, traces, and logs from your services, from your infrastructure. I briefly showed some receivers that you can set up to configure even some infrastructure metrics from your services. Of course, there's a constant evaluation and ongoing support. Maturity in OpenTelemetry is really great. We are also highly collaborating and actively investing in OpenTelemetry. I have some information here on the GitHub repository that I used for this demonstration as well. If you want to look into this, as part of the GitHub repository, I'm using different branches. So if you look into this, you'll notice there's different branches for the different types of instrumentation. By the way, maybe quickly highlighting, there is also a hybrid approach in place. And just to show how this could look like, imagine you have the auto instrumentation and you're just using the Java agent. The method that I showed where we have the execute long-running task, I could also add in some environment variables here. One that is called OTel instrumentation methods include. And here I could then specify the package, my class, and all of the methods that I'm using as part of my class. I could define what should be instrumented and go deeper. I don't have to use manual instrumentation for this specific aspect. I could also exclude some data. So there's also detailed control over what is happening as part of the configuration when you're using auto instrumentation with the agent and not using SDKs. So there's various branches in here. There's some other reading material if you want to look into this. And with that, I don't know if there's any final questions, but that was basically what I wanted to show you today. I hope it was interesting and you got some indication of or information about how does it, how to get started, what are the pros and cons of using various different approaches. And I'm looking for any final questions that you may have.
Harry, so first of all, a huge thank you for your insights and all of the information. There is one question from Miriam, so let's do the following. First of all, again, thanks for your showing up here and this nice presentation. So let's go over into this hopefully dynamic discussion part of the talk. So Miriam is first. Do you have any recommendations on how to set up alerting based on OpenTelemetry?
So it of course depends a little bit on the tool that you're using for your OpenTelemetry backend. The capabilities and so on that this platform provides. I can speak a little bit about the capabilities from a New Relic perspective. We have various kinds of alerts that you can configure, very detailed on like more static alerts. which is probably not my preferred way of doing it, like static in the way of, I want to get an alert if the response time of my application is larger or slower than 2 seconds response time. This could be a good use case, depending upon your specific setup. I am a big fan of doing this more dynamic. So basically adjusting the alerting strategy based on maybe the historical performance. To give you an example, maybe you have like a typical load where your users coming in and using your applications, Monday to Friday, they're coming in Monday, the response time goes up a little, which is more or less natural because you have a lot of users, starting to use your services and your applications. And this is always happening at a certain point in time. Then you can have a more dynamic baseline alerting strategy where you define or you basically define the threshold on how closely do you want to monitor your baseline. And then depending upon your threshold, you can be closer or wider away from the baseline. But this is probably a better way of using a good alert. There's various things around anomaly detection, outlier detection. We at New Relic, we don't make a difference. Basically, from an alerting perspective, whether the data is coming from our agents, from OpenTelemetry, or whether you're sending in data through other forms of ingest. So not sure if this answers the question. It's a little vague, I know, but it probably also very much depends on the backend that you're using for your data.
Thanks. I have also another question. So as an AWS fanboy and doing at least some cloud native development, what's your opinion about comparing the cloud native approaches? So for example, when speaking about AWS, you have CloudWatch and other services to what you just showed us. Are these alternatives to each other, or are they additions to each other?
So they are, in a sense, additions because you may be using CloudWatch or these cloud native services to centralize the collection of your logs, for example, or your traces into AWS X-Ray or CloudWatch logs. But what I'm typically lacking, there's kind of like a contextualized view of putting all of the things together, because typically it is not only the aspects of the cloud native services. Of course, maybe if you are just relying in using AWS centric approach, and you're just using maybe some lambdas and some DynamoDB, you maybe the visibility that you get is probably sufficient, maybe. But in general, or in typical use cases, this is much more than just these cloud native services, because maybe you have some front end, some web front end, or some mobile app that talks to your backend or gets triggered, and you also want to capture this type of telemetry and have a complete end-to-end view, like we've seen in this example, right? In general, I think all of the AWS services as well, they have some form of OpenTelemetry plugin capabilities as part of their service. For example, Lambda uses some OpenTelemetry layers or some wrappers around the Lambda functions that you can configure. There's this AWS AWS distribution for OpenTelemetry that is available. So, but in my experience, I think the ways to analyze the data, alerting and stuff like that, is probably more suited towards like a full observability backend. But it may depend on your use case. But I think there are ways on how to achieve a similar way with just the cloud native services as well.
Thanks. And Christian finally noted in the chat that the plugin I think he provided for IntelliJ IDEA is usable or can consume your files in your repository. So everything is also working with IntelliJ IDEA. Nice
Okay.
thing. All right. So yeah, there are seemingly no more questions. So Harry, thanks again for showing up here, and it was a great talk. As a reminder, next week, so on the next Tuesday, I'm going to talk about AWS, or basically developer certifications, and the example of AWS certifications. This will be in German, but having a look at the poll at the beginning of our talk here, maybe of interest for a lot of visitors here. So thanks again, and hopefully the recording is going to be on YouTube, and the slides are going to be on the website. And yeah, to all of you, I'm going to stop the recording, but staying here, so everyone who wants to talk, have a chat with Harry or to each other or me can just stay. So have a nice evening, stay healthy, and see you next time. Ciao.
Thanks so much for showing up.